Hi there, this is Malloy here at the Worldwide Center of Mathematics. In this video, we're going to discuss how to prove that a quadrilateral is a parallelogram using diagonals. So here we have a quadrilateral that looks like a parallelogram, but we don't know that for a fact. But we would like to prove that it's a parallelogram. And we're asked to use the diagonals. So let's draw a diagonal from the top left to the bottom right, and the top right to the bottom left. There's an interesting property of parallelograms that states if the two diagonals bisect each other, in other words, if these two line segments are congruent and these two line segments are congruent, that is actually enough information to show that the quadrilateral is a parallelogram. Of course, you probably won't be given that right off the bat. You'll probably be given a problem that's a little bit trickier. So let's assume that we want to show that's true. Let's go ahead and label all the important vertices, A, B, C, D, and we'll call the center E. All right. Suppose that we are given that the angle ABE is congruent to the angle CDE. And similarly, we are given that the angle BAE is congruent to the angle DCE. And lastly, we're told that the line segment AB is congruent to the line segment CD. Okay, let's go ahead and mark off the information that we know. We know that these are congruent. We know that these are congruent. And we know that these are congruent. Great. So, right off the bat, we can see that this triangle, DEC, is going to be congruent to this triangle, BAE, because of the ASA congruence postulate. So let's go ahead and write that down. We'll see in a second why that will be helpful for us. Triangle CED is congruent to triangle AEB. Okay. Well, from here, we can quickly show that this line segment is going to be congruent to this line segment by using CPCTC. Corresponding parts of congruent triangles are congruent. So we know that line segment DE is congruent to the line segment BE. And similarly, we know that this line segment is going to be congruent to this line segment by the same theorem. So AE is congruent to CE. But this gives us exactly the information that we need. These two line segments form a larger line segment, and they are congruent. This means that this entire line AC is being bisected by the line DB. But the opposite is also true. The line segment DB is being bisected by the line segment AC. Thus, we show that the two diagonals are bisecting each other, which, as we discussed earlier, is enough information to prove that ABCD is a parallelogram. My name is Malloy, and we've just discussed how to prove that a quadrilateral is a parallelogram using the diagonals.